morning, everyone. I hope you are having a wonderful day. Today what we're going to be talking about is solids of revolution. Not around the x-axis. So what we're going to do is we're going to start with our first example going around the y-axis, and then we'll look at some other horizontal lines from there. So what we want to do is find the volume of the solid generated by revolving y equals x cubed. Y equals 8. And y equals 0. Around the y-axis. So first thing we're going to do is we're going to go ahead and just do a quick little sketch of this. I know I have to get from 0 to 8. 6, 7, 8. At 0, plug in 0, I get 0. Plug in 1, I get 1. Plug in 2, I get 8. Okay, so I know my graph is going to kind of look like this. And it says I am going from y equals 8 and y equals 0. So I'm going to take this section of the graph and I'm going to be rotating it around the y-axis. So I know I'm spinning in this direction. And so we're going to be taking this shape right here and we're going to be rotating it around the y-axis. And so what that's going to do is it's going to give us this kind of shape right here that we'll have when we get done rotating it. So you saw in the video from Khan Academy, I hope, that when you're going around the y-axis, the equation for volume is pi, your integral from a to b, but this time our y's are our a's and b's. So y equals a to b, and our radius function squared dy. Okay, so whenever we're rotating around the y-axis, everything in our integral is going to be y's. Okay, so if we're looking at this, I can go ahead and start to fill this in. Our volume is pi from, we're starting at 0, we're going up to 8, but I need a function that has y's written in it. So my function here says y equals. I need it to say x equals so that my function is in terms of y. So I need to have it going the other way. So if I take the cube root of both sides, now I have a function. This function is f of y, right? Because to be a function of y, your equation has to have y's in it. So over here, if I look, I can see that the radius of the circle that's being created goes all the way from the y-axis, at every point from the y-axis out to the function itself. It's a solid disk that's rotating around through here. Okay, so my our function is just my f of y function. So I'm going to go ahead and fill that in here. So that's the cube root of y squared dy. So now we just have to evaluate this integral. That should not be a big deal. So this is, if we rewrite it, pi 0 to 8 y to the 2/3 dy. Go ahead and do that. If we add 1 to that, that's y to the 5/3 times the reciprocal, which is 3/5. Okay, and we're going to multiply this whole thing by pi, and we're going to evaluate from 0 to 8. So we can go ahead and figure out how much that is. So again, I'm just going to multiply by pi when I get done. This is 3/5 8 to the 5/3 minus 3/5 8, oops, not 8, 0 to the 5/3. So when we do that, that's pi times the cube root of 8 is 2, and 2 to the 5th is 32, so this is 3/5 times 32 minus 0. So this is 32 times 3 is 96 pi over 5. Okay?